you ever borrowed a loan and did you need to calculate your monthly payments and your total payments? Did you struggle with that? Worry no more because our project is just about that. Our system works as follows. We ask the users to input three things. First, the number of years they want the loan for, the loan amount, and the interest rate. Our algorithm calculates a few quantities under the hood. First, it calculates a monthly interest by dividing your annual interest rate by 12. Then, it uses this quantity in our formula to calculate the monthly installments that you have to pay. We use this information to calculate the monthly payments that you have to pay and the total amount that you will have paid when you have paid out your loan. We then display all this information and other information about your loan in a user-friendly way.
As our project is pretty big, we decided to use a strategy to divide it into subtasks and solve each of them in our code. First we have the input, then we have the input checking step where we check for input validity, which means, for example, if the user has entered a string where he should have entered a number, that would be invalid input, and then we would prompt the users to the same input again until they enter the right format. And we also ask the users at the end of each input block if they like what they've entered. Maybe they want to change it, they have this option. The calculation section consists of all the math that we do and all the logic that we do. As we want to use our program in a practical sense, we have invented numbers and properties of each type of loan, so they are feasible. We have car, student, and house loans. For example, if the user wants to take out a car loan, he could do that for a maximum of 10 years, and he could take out a maximum amount of $10,000 with a minimum interest of 3%. We also introduced the notion of a linearly scaling interest rate with the number of years of the loan. As you can see, the more years, the higher the interest rate would be. And of course, another strategy that we use is the equation strategy, because it is in the core of our algorithm. We have to calculate the monthly payments of a user. In order to make our code clear, we use a separate variable for the numerator and the denominator of the big formula. After we have our monthly payment value, we could use it to calculate the total payment for the user. Here's the formula that we thought of. After this step, we have our final step, which is to display all the information to the user in a user-friendly way. As you can see, we provide the user with a detailed summary of his loan. We print out the loan amount, the number of years for payback, the monthly payment, the yearly interest rate, and the total payment. Now we'll look at a demo of our program. So first, my name is Stefan. I'll enter that. Let's say that I would like to take out a car loan. So now we input the three parameters of our loan. First, the annual interest rate that we would like, let's say 3%. Then the number of years, let's say that I want to take it for 2 years. And the loan amount, 5,000 is sufficient, I think. So now the program tells us that we have requested this loan. If we want to continue, we'll just say yes. So now our program says that the minimum interest rate for a 2-year car loan is 3.33, and this is higher than what we had in mind. So now the program would ask us if we accept those conditions. If we accept them, We could just say yes. And here's our loan. Now, the work was distributed as follows. The flowchart was made by Jinkai and checked by Mohammed. The pseudocode was made by me and checked for errors by Mohammed. The Python code was created by Mohammed and I checked it. The final report was written by Mohammed and also me and Jinkai helped him. The final video was made by me and Jinkai added the subtitles. Our project didn't go problem-free. We faced two problems during the making of our project. The first problem was to find the right formula for the monthly interest rate, calculated as a function of annual interest rate. We first thought that we have to use a term called effective interest rate with a more complicated formula than we use. But then it turned out that we just had to divide the annual interest rate by 12. The second problem that we faced was achieving the right flow of code, because as you have seen in the demo, the program asks a lot of times the user to input a yes or no signal in order for the program to continue. And if the user said no, we had to determine the right place where the program should return the user. Our first thought was to return the user to the beginning of the program, but that isn't the most efficient implementation. Now we just return him to the beginning of each step in our program. That was Project Interest Rates. Thank you for watching.